Hi everyone, and welcome to the first theoretical approach, first theoretical class regarding airplane and aircraft engineering. So, first of all, what we need to understand is the different elements, the main elements, that compose an aircraft. So, as you may know, we have a fuselage, which its intention is actually works as a central body, and of course it will accommodate crew and payload. So basically all the payload, all the cargo will go into the fuselage. Okay? The main structure actually attaches the different elements of the aircraft. So this is important in terms of the structure, okay, because you will understand that severe loads, more structural demanding loads will actually appear on the boundaries of this fuselage with the wings or with the tail, for instance. Also, it is kind of, you have to choose between aerodynamic geometry, alright, which of course a little fuselage would be better, because if we have a bigger fuselage, we have more drag, we have more impact on the wing to the aircraft, so a smaller geometry would be the best. However, we need also some volume. We need to cover some seats, we need to cover some cargo, okay? So it is kind of a balance between aerodynamic geometry and volume, all of the fuselage, okay? The wings, as you know, basically what they do is provide lift to the aircraft and provide some force, some upward force, which is able to counteract the weight of the aircraft. Now, the wings itself have an aerodynamic cross-section, which is named usually an airfoil, which is kind of optimal in order to obtain as much lift as possible, considering the different velocities, okay, the different conditions at which this aircraft will operate. If you have, for instance, a ship, if you have a boat, and you need to produce some lift, this will be different than in the case of an aircraft, because you would have different conditions. Instead of air, you would have water. Okay, that means that depending on the kind of flux, depending on the kind of material that you have in the surrounding, it may be completely different geometry. Okay, this is to optimize the lift. As always, in terms of aircraft, okay, the most important element is to increase lift in order to, get upwards, but also reduce as much as possible the drag, because this would a big drag would also be a problem to the aircraft and would be a structural problem. And not only that, but it actually means that we need more energy, we need more thrust, we need a bigger engine, okay, to get the aircraft moving. So in the end, a lot of effort is put into optimizing the airfoil and optimizing the geometry of the wing in order to optimize the ratio between lift and drag. Some other elements which are important are the tail, okay, which is known also as empennage, which in general provides stability to the plane. This is a key element to provide stability, okay? You will have vertical and horizontal stabilizing surfaces. By surfaces I mean not only the tail itself, but also the moving surfaces that we will have, okay, like this one over here, as you can see, which provide a different stability depending on the demands of the pilot. Okay, it may provide also some changes, some orientation changes to the aircraft, depending on what the maneuver or what the changes we need for the aircraft. Okay, of course it stabilizes for yaw and also for roll. Okay, it will stabilize all the aircraft, and we have in fact several tail configurations, which we will discuss later. The idea is that we don't only have this kind of an inversed T configuration, but there's a lot of other configurations with some limitations, okay? Now, in propulsion engines, what we have is actually an engine which kind of mixes air from the exterior. This is the air which is present on the surrounding of the aircraft at a certain velocity, of course, at the cruising velocity of the aircraft. And then actually this air goes into the engine, and inside it burns with a mixture of different fuels, okay? Now, the idea is that we transmit rotational motion into thrust. So this air entering the engine kind of converts all of these jet engine to actually start moving, rotating, and therefore will generate some thrust. We have turbofan, turbojet, turboprop, depending on the conditions that you are interested, and it operates with Newton's third law. So this means that because the air will be ejected at a higher velocity, the aircraft will actually move further. Okay? So this is the main elements and introduction that I wanted to do. Now we can focus more detailedly into each one of these topics.